Hello, good morning everyone. Our lesson today talking about chords and arcs. All of us we know that the chord is the segment whose end points on a circle, like the segment PQ. This is our chord. Here we have some theorems to explain the relation between the central angles and the chords, central angles and arcs and chords. At the first, let me explain the first theorem, theorem 12.4, the relation between the central angle and the arc. If we found entire this circle within a circle or congruent circles, congruent central angles have congruent arcs. That means if we have central angle like angle AOB congruent to the angle COD, then the two arcs AB and the arc CD are congruent. The converse of this theorem, if we found in the same circle or congruent circles the two arcs AB and CD congruent, then the two central angles AOB and COD are congruent. The second theorem, the relation between the central angle and the chord. If we have within a circle or congruent circles congruent central angles, if we have an angle AOB, central angle AOB and COD, if they were congruent, then the chord AB and the chord CD are congruent. The converse, if we found the entire this circle or congruent circles, if we have chords AB and the chord CD, if they were congruent, then the central angle AOB and COD are congruent. The third theorem explains the relation between the chords and the arcs. Here we have circle, if we have circle or congruent circles, if the congruent chords like AB and the chord CD, if the two chords are congruent, then their arcs are congruent. The converse of this theorem, if we have two chords are congruent, then their arcs also are congruent. The chord AB congruent to CD, then the arc AB congruent to the arc CD, and its converse, if we have the arc AB congruent to the arc CD, then the two chords AB and CD are congruent. Let's solve some questions. In the diagram we have two circles, circle O and circle P are congruent. The given here we have the segments BC and DF are congruent. The two chords are congruent. According to the previous theorem, the relation between the chords and the central angles, or the chords and the arcs, like that, let's find the conclusion about that. If we have two chords are congruent, BC congruent to DF, then the central angles are congruent and the arcs also are congruent. Then the arc BC congruent to the arc DF, and also the central angle BOC congruent to the central angle DPF. Here we have another properties or theorems about the chords. Here, if we found the two chords in a circle, are equidistant, the same distance from the center of the circle, then both of them congruent. Then if we found the distance from the two chords and the center, if it was the same, like OF equal OE, then the two chords AB and CD are congruent. The converse of the theorem, if we found that the two chords are congruent, AB congruent to CD, then they are equidistant from the center of the circle. That means OF would be equal OE. Let's solve this question. What is RS? According to the given here we have this distance, this length the same, then both of the two chords equidistant from the center because they have the same length from the center. This distance is 9 and the other distance 9, then both of them congruent, then the chord PR congruent to the chord RS. Since we have this distance are equivalent from the midpoint, that means this distance 12.5 and the other distance QR 12.5, then the length of PR 12.5 plus 12.5 equal 25, then RS also equal 25. What is the value of the variable x? According to the given, here we have two chords are congruent. According to our converse of the theorem, this chord 36 and this chord 36, then both of them equidistant from the center. Then this distance is 16, then also the other distance x would be 16. Even more about the chords. There are some theorems about the chord and the diameter. If we have diameter like the diameter AB, if this diameter perpendicular to the chord, then this also bisector to that chord. Then in a circle, if a diameter is perpendicular to this chord CD, then it bisects this chord and its arc. Then this distance EC equal ED, and this angle here right angle because this diameter perpendicular to the chord. We have another theorem. If we have a diameter, if we found this diameter bisected the chord, then this also is perpendicular. In a circle, the perpendicular bisector, this distance, the perpendicular bisector of a chord contains the center of the circle. That means if we have only radius, like radius OA, not all the diameter, it will be the same perpendicular bisector to the chord. If this radius perpendicular to the chord CD, then it's also bisect CD. Then whatever this was diameter or radius, it will be the same. Let's find the measure of this part. Here, what is the value of R? According to the given, here we have radius or distance, not radius. According to the previous theorem, contains the center of the circle. Here we have this distance perpendicular to the chord LM. Then according to the theorem, then this is perpendicular bisector, bisects the chord LM, then LN equal NM. Since LM equal 14, then LN equal 7. Using Pythagorean, we can find the length of the hypotenuse KL. Then R squared equal 7 squared plus 3 squared. Then R squared equal 49 plus 9. Then R squared equal 58. Then to find the length of R, we will use the square root of 58. Then R equal 7.6. Let's solve another example. Here we have the diameter, as you see, or this distance DC perpendicular to the chord AB. According to our theorem, then this is perpendicular bisector to the chord AB. That means AC equal CB, then CB equal 7 meters. How to find the AB? Since we have two equivalent distance, C is midpoint, AC equals CB, then the whole length of AB is 14. How to find the AD? as we explained in the previous slide, we will use Pythagorean to find the length of AD. Then this distance squared equal 3 squared plus 7 squared. Then AD squared equal 49 plus 9 equal 58. Then AD equals square root of 58 equal 7.6. Thank you for listening and have a nice day.